Hey, good morning everyone. My name's Eric, and today we're going to be covering angular speed and linear speed. So the problem that I have set up here is a formation of Navy ships. You can see we have the USS Math, the USS Algebra, the USS Trig, and the USS Calculus. We're of course on the USS Trig, so we want to determine our linear speed by using this formula where linear speed V equals radius R times angular speed omega. So first we need to determine our angular speed omega, which equals the measure of our central angle theta over time. So in this case, we're concerned with 1 revolution an hour. So that's our time. And the measure of our central angle theta, since we have an entire revolution, is 360 degrees or 2 pi. So our angular speed is 2 pi an hour, which we can now plug into our equation for linear speed as it relates to angular speed. So linear speed equals our radius r, which is 6 for the USS Trigonometry, 6 nautical miles, times our angular speed of 2 pi an hour, which if we multiply across gives us 12 pi nautical miles an hour. So this would be our linear speed, or we could express that in decimal as 37.7 nautical miles an hour when rounded to 2 decimal places. So 12 pi an hour, or 37.7 nautical miles an hour. So as you can see, while the angular speed is the same for all 4 ships, because they're completing 1 revolution in 1 hour, the ships with a greater radius are having to travel a greater distance, which means their speed is going to have to be higher. So you can see the increase in speed as it correlates to a greater radius. With the USS Math going 12.5 nautical miles an hour, the USS Algebra at about 25, the Trig at 37.7, and finally the USS Calculus at 50.27 nautical miles, which is pretty impressive. So thanks guys, that's angular speed and linear speed, and I want to give a big shout out to CS2 Fryer for helping me film this.